Good morning. My name is Gordon Stead, and at the Material and Energy Systems Lab at UGA's College of Engineering, we are considering ways in which we can improve the uptake of renewable energy, reduce emissions, and promote solutions that may apply to the developing world context as well as our own. We therefore suggest an approach termed community-scale generation that aims to meet all of these objectives. In the late 19th century, Thomas Edison and George Westinghouse fought for control of America's electrical market through their rival technologies. Ultimately, alternating current, or AC, developed by Nikola Tesla, prevailed over Edison's direct current, or DC, as it allowed electricity to be transmitted efficiently over long distances. But today, as we seek sustainable solutions to our impending energy crisis, perhaps a return to DC electricity is worth considering, given its synergy with solar energy, distributed generation, and its high efficiency. In the community scale generation, or CSG concept, solar photovoltaic arrays are ground-based and supply a nearby community of, say, 50 to 100 houses. Being so close to the consumers, the whole system, including short-distance transmission, can run entirely on DC electricity. As well as avoiding most of the 5% average energy loss in US utility electrical transmission, energy demand can be reduced by up to 35% through a combination of ultra-efficient DC household appliances and eliminating losses through AC-DC conversion. Unlike rooftop systems, ground-based arrays can be mounted on solar trackers, which allow the PV cell to generate substantially more power as they face the sun directly during the daylight hours. Here in Georgia, dual-axis trackers could provide a boost of up to 30% energy over the year compared to standard flat arrays. These combined energy sources, along with suitable battery systems, could conceivably allow communities to supply all of their own energy sustainably and at quantities sufficient for a high level of comfort and connectivity. By analogy, many communities in the world supply their water on a similar community scale, drilling down to pump water from a well, distributing it to individual houses, and storing it for later use. The community scale generation concept is, in effect, another vertical well, but facing upwards, catching the natural supply of energy from the sun and using batteries for storage. If our consumption in parts of the highly developed world is met just by our local supply, we can seriously limit our impact on downstream and upstream on the rest of the world. And if the developing world can leapfrog past utility scale technology directly to a community scale concept, we may yet achieve our goals of both sustainability and development. Thanks so much for watching this presentation, and please let me know by email at gordon.stead@uga.edu of any questions you may have. Thank you.